My name is Ted Monholland, and we're working on our methods project here.
Okay. My name is Toluwani, and here we are working on methods project. Okay, let's get started. Um, okay, these are the things we're gonna work with. These are the voltage source connected to ground and PA. Then we have an op amp here. We have a transistor. We have a light dependent resistor. 3 resistors that we're gonna use with measured values, and our wires and our light bulb. Okay, so Ted is gonna describe the light bulb and everything for us. Alright. Okay.
Okay, this is the light bulb that we created in Lab 2,
Mm-hmm.
and here is the schematic for it right here.
Okay.
So our voltage source is 12 volts.
Mm-hmm.
It's going to come in here, and each LED is going to consume, it's going to use 3.1 volts.
3.1 volts.
So total here is going to be 9.3 volts.
Mm-hmm.
And we want each of these, since they're in parallel, each one's going to be 12 volts.
Okay.
So we had to calculate a resistor to make this thing 12 volts, and it turned out to be 90 ohms. But we didn't have a 90 ohms, so we're just going to use a 100 ohm resistor for each of those. And so here's the final product here. Each of these right here are in series. These are the resistors over here. We basically just soldered everything together and used electrical tape to connect them all so that nothing was short-circuiting with anything else. And we just used this Gatorade bottle to attach it all together. And here's what happens when we plug it in. Just like that.
So that is it.
Everything lights up.
Okay. Yep. Okay. Now I want to describe how the LDR works. The LDR works on a concept that when there's light, the resistance of the LDR goes low, and when the room gets dark, the resistance goes up. So we are going to show this in practical ways. Yes. Just going to hook this up, the voltage source, and I'm going to use this. Put this here, this to negative. So right now, this is normal room light, so the resistance goes down. So right now I'm going to use my hand to cover this, and the resistance, if it goes up to 2000 kilo ohms, like 245, about 400, and still going up. Okay, like 470 kilo ohms and all that. Yeah. So that is how the LDR works. It works on the principle of light. When there's no light, the resistance goes down. And when there's light, the resistance goes up.
Okay. Okay, now we're going to describe what the op amp is. This device right here. It has 4 plugins on each side. And what it does is it compares 2 voltages. I'll switch to the other page here. There's going to be 2 different voltages coming in here and here. And what it does is it compares them, and depending on what the result is, V out is either going to be V supply or it's going to be V minus supply. And if V1 is greater than V2, then based on this graph up here, V out is going to be V positive supply. So if you look over here, V out right here would turn into V plus supply. And if V1 is less than V2, then we're going to go down here. So V out is going to turn into minus supply, which is this one right here. And the way we're going to create the 2 different voltages is each one has a voltage source of 12 volts, and we're going to alter these resistances to get the voltage that we want. And the LDR that we talked about in the first video is going to be this right here in place of the potentiometer. And so this voltage is going to be controlled by the light. And this voltage is going to be held constant at around 5 volts. So when this resistance changes due to light, it's going to change this voltage, and that's going to cause a change between the result, and it's going to determine whether V out is V minus supply, which is going to be 0, which would mean that the light bulb doesn't turn on, and if it's V plus supply, V out would be a higher number, which would make the light bulb turn on.
Okay, now we are going to describe the transistor. This small thing. Okay, so this transistor works like a switch. It's going to act like maybe it's going to turn on the current or turn it off. This is the base of the transistor. This is the emitter, and that's the collector there, according to this graph here. So this transistor acts in such a way that when a certain amount of current flows through this, depending on the resistance, because the resistance affects the current, it's gonna connect C. It's gonna connect this C here to E. Like it's gonna make it a short circuit here, and it's gonna allow the I load, that is the big current, to flow through it, thus turning on this bulb. So that is just the function of this small thing here, the transistor. I'm sorry. Yeah.
Okay, so here we have our completed circuit, and we have the op amp right here. We have our transistor right here. We have these two areas right here. These are going to be these are going to create the two different voltages that go into the op amp. This is our light dependent resistor, which is going to control this whole voltage right here. And we're going to connect the light bulb to this side of the transistor and V out on the op amp.
So I'm going to connect the light bulb. This is the positive side of light bulb, and that is the negative side of light bulb. Okay. So the light bulb is connected, and I'll go on and put output on. So it comes on whenever I cover it. That means it's in darkness, like the LDR. Whenever I move my hand, and it comes on and goes off like that. So
Did you get it to work?
Yeah, it is.
Yep.
Thanks. So that is it. Like that is the main demo of everything.
Yep. All right. Huh?
Bye.